You are listening to The Vocal Technologist. Spoken tech for your ears.
Tools are getting better, output is getting worse. Both are true.
It really is the great irony of infrastructure right now. Like, we build these smarter systems and they just find entirely new ways to fall apart.
Yeah, exactly. Welcome to Vocal Technologist, where we take a proper look at what's actually happening in infrastructure and DevOps. I'm really glad you're here. We've got a massive stack of notes to pick apart, all circling this weird tension.
Right.
On one side, you have this hyper-complex AI orchestration, agents writing code, managing systems, just running wild.
Yeah, and on the other side, there's this massive, almost desperate industry pushback toward boring, reliable basics.
It's a genuine tug of war. Like, teams are trusting AI to do heaps more, but the underlying plumbing has to be more resilient than ever just to handle the chaos those agents create.
Spot on.
So let's start with the AI reality check. Armin Ronisher made this brilliant observation about the newer Anthropic models. Like, they understand complex tasks, they generate the correct edits,
Right.
but they're actually getting worse at following strict tool schemas.
Yeah, it's a phenomenon people are calling schema slop.
Schema slop. I mean,
Well.
that sounds a bit ordinary. What's actually causing it?
Well, it comes down to how these models are handled post-training. Like, they're put through their paces on these closed-source, very forgiving harnesses, things like Claude Code.
Okay.
And in those environments, if the model, say, hallucinates an extra JSON field or relies on a weird alias instead of the official command,
Yeah.
the harness just quietly fixes the error behind the scenes, lets it slide. So the model learns that close enough is good enough.
Wait, so they're getting dumber at following basic rules because we're just coddling them too much during training.
That is exactly it. Think of it like hiring this brilliant executive assistant, absolutely genius at strategy,
Right.
but they absolutely refuse to use your company's standard expense forms. They just, scribble everything on sticky notes because their last boss just dealt with it.
Oh, wow.
And when you drop that same assistant into a strict grammar-constrained system where a missing comma throws a fatal error, they just break.
Because they've never had to be precise.
Exactly. The token probabilities for following the rules have been smoothed over by just way too much leniency.
That is heaps frustrating for anyone building custom agent harnesses. And the pressure to fix this isn't just technical, right? It's economic.
Oh,
Look
absolutely.
at GLM 5.2. I mean, this is an open weights model starting to seriously challenge the frontier labs.
The economics there are wild. Like, GLM 5.2 offers near Opus quality output for coding workflows. It might be a little bit slower interactively, sure, but it costs less than 20% of what the big frontier models charge. We are basically staring down the barrel of an AI margin collapse.
Right, because if the open models are that cheap, developers are just going to use OpenAI and Anthropic compatible endpoints to swap them in.
Yep.
But since all these models, expensive or cheap, are prone to this schema slop, developers are having to build these massive workarounds.
Yeah, these incredibly resilient meta harnesses just to keep the AI on track.
Because the agents crash.
Yeah.
They fill up their context windows and just forget what they're doing.
Exactly. So you see projects like Planning with Files. It's this open source tool that gives AI coding agents persistent, crash-proof memory.
Go so.
It literally stores task plans and findings in markdown files right on the local disk.
Right, which is mirroring the exact context engineering approach used by Manus.
Yeah.
You know, that AI agent company that got acquired for $2 billion.
Yeah, Manus.
And the insight here isn't just that they use files. The insight is that we're retrofitting 30-year-old software concepts to act as short-term memory for neural networks.
Because they need it.
Yeah, neural networks literally cannot be trusted to remember their own train of thought, so they have to write it down on disk.
Right.
When the agent inevitably loses its mind, it just reads the markdown file and picks up where it left off.
Exactly. And the tooling goes even further to enforce discipline. Like, take Gastown.
Okay, Gastown.
It's a multi-agent orchestrator. You can have Claude, Copilot, and Gemini all working on different tasks at the exact same time. And to keep them from blowing up, it uses Git-backed storage to preserve their state.
So every thought process is basically a commit.
Exactly.
If an agent crashes, the Git history survives, then you just revert to the last sane thought.
That's the mechanism. It uses a merge queue, they call the refinery, to process the completed work from the agents.
Right.
And they have this federated network called the wasteland, where multiple instances can share work and build portable reputation scores.
I mean, that is proper Mad Max stuff.
It really is.
But it's built for survival.
Yeah.
And then you have Ruflo, which wraps models with over 100 specialized agents gives them self-learning memory, and uses enterprise-grade federation with mutual TLS.
Yep.
It's entirely about forcing unreliable models into a highly reliable, structured swarm.
Which is necessary because if you don't force them into a structured swarm, the alternative is letting them roam free.
Which brings us to the part nobody is talking about.
Yeah.
If isolating AI in these strict meta-harnesses is the only way to keep them functioning, it completely explains the security panic we're seeing.
Oh, for sure.
Because if these agents are hallucinating and crashing, giving them the keys to your production environment is incredibly dodgy.
It is the ultimate security nightmare. You have these autonomous workloads that might just decide to do something totally unpredictable with your cloud infrastructure.
Yeah.
That's why we're seeing cloud providers step in with hard perimeter defenses. Like Google Cloud rolled out new VPC service controls specifically for agentic AI.
How does that actually stop an agent from going rogue, though?
Well, they're adding identity-based access rules, and they pair those with model context protocol attributes.
Okay.
So if an autonomous workload gets compromised or just, decides to query a sensitive database, it shouldn't.
The VPC intercepts it.
Exactly. It checks the network-level security rules against the agent's specific MCP identity and just prevents data exfiltration. The agent hits a hard roll.
But securing the network is only half the battle, right? You also have to secure the runtime environment where the agent actually executes its code. Right. Which brings up this open source project called Cube Sandbox. It uses Rust VMM and KVM to spin up hardware-isolated environments for agents.
And the underlying tech there is what makes it viable. Like KVM is kernel-level virtualization. It's secure, but usually quite slow to boot.
Yeah.
But Rust VMM provides these modular building blocks for hypervisors. When you combine them, the performance metrics are just incredible.
Right, because Cube Sandbox spins up a secure environment in under 60 milliseconds with less than 5 megabytes of memory overhead.
Which is ridiculous.
The 60 milliseconds is the critical part. If it takes 5 seconds to spin up a sandbox, your swarm of autonomous agents is going to time out or just stack up.
Yeah, you'd have a massive traffic jam.
It's like dropping an unpredictable guest into a padded soundproof room that takes 60 milliseconds to construct. Let them scream, let them break things. The room contains the blast radius perfectly.
That isolation is strictly necessary, though, because of why agents struggle in production in the first place. The SRE community calls it the four-body problem.
I love this framing.
Yeah.
Break down the four-body problem.
It's the idea that autonomous operations fail not because the AI isn't smart enough, but because the operational context is hopelessly fragmented.
Right.
To fix an outage, an agent needs four things to align. First, the code itself.
Yep.
Second, the infrastructure state. Third, the runtime signals, so the metrics and logs. And fourth, the institutional knowledge.
Okay, put yourself in this scenario. Imagine you're handing the pager to an AI agent at 3 a.m.
God help you.
Right. The agent can read the code, it can read the logs, it sees the database query is timing out.
Yep.
But if it doesn't know why you configured that database specifically that way last year,
The institutional knowledge.
exactly, it's going to try a textbook fix that takes your whole system down.
Precisely. Like, why is there a weird rate limit on this specific endpoint? Oh, because of a compliance rule from 2 years ago.
Right.
Without a unified version knowledge graph tying those faux bodies together, the agent cannot reason accurately. It just lacks the human context to act safely.
Spot on. By the way, if you are keen to keep up with how this stuff is shifting, flick on the notifications for the show.
Honestly, until we solve that four-body problem, handing over the pager to an AI is just asking for a massive outage.
Right, so here's where it gets interesting. While the AI side is building these incredibly fragile Rube Goldberg machines, the rest of the infrastructure world is desperately paddling back to simplicity.
Oh, big time.
If building padded rooms and giving AI a 30-year-old version control system as a brain is the only way to keep it from destroying production, it completely explains the massive backlash we're seeing on the data side.
Yeah, people are exhausted by this fragility.
There is a literal migration back to the most boring database on Earth.
The great retreat to the basics. And the most prominent example is the Postgres is enough movement. But wait, I have to push back on this. We spent a decade splitting workloads. Redis for caching, Kafka for queues, specialized vector databases like Pinecone for AI.
Yep, the micro database era. You reckon teams are ditching their fancy 5 database setups just to go back to Postgres? I thought you were having a lend. I mean, Postgres wasn't built for high-dimensional vector search.
Yeah.
If you're running an enterprise RJAG application at scale, Postgres is going to buckle under that compute load compared to a purpose-built vector DB.
Look, at a massive global scale, Yes, Postgres will buckle, but the reality is that 95% of companies do not have pinecone scale data.
Fair point.
They're realizing the operational cost of managing a highly fragmented stack, like synchronizing data between 5 different systems, is just too high.
Right, it's an absolute nightmare.
Postgres can handle caching patterns, job queues, full text search, and vector search perfectly well for the vast majority of use cases. You just avoid the headache of adding a new data store before you truly need that specialized scale.
Okay, fair. But scaling Postgres has its own well-known headaches, especially with connection pooling.
Oh.
Every connection to Postgres consumes memory. If you have 10,000 autonomous agents waking up and hitting the database at the exact same millisecond, Postgres is going to fall over.
That is true, which is exactly why the ecosystem around it is evolving so fast to fix those bottlenecks. Like, look at PGDog.
PDDog.
Yeah, it's a new Postgres connection pooler. Historically, connection poolers break certain database features. Session state, set commands, things like listen and notify.
Right, because the pooler is just shuffling connections around indiscriminately between different clients, so the session state gets lost.
Exactly. But PGDog uses a built-in SQL parser to track per client session state intelligently.
Oh, that's clever.
And the crucial mechanism is that it runs on a multi-threaded Tokio architecture.
Okay, Tokio in Rust.
Yep. Tokio handles asynchronous I/O across multiple threads. This means PGDog can handle massive traffic bursts, like your swarm of 10,000 agents, without choking the CPU or forcing you to shard connection pools across multiple proxy processes.
It just handles the concurrency safely. The other wild thing I saw in a Postgres world is this new trick for partition pruning. Normally, if you partition a massive database by timestamp to keep queries fast, and you query by a different column, say a session ID, the database has to scan every single partition anyway. It defeats the purpose and is horribly inefficient.
Right, but engineers found a brilliant way around it using check constraints.
How does that work?
If you encode the guaranteed relationships directly into the data, adding per partition session ID range constraints, the database engine reads those constraints before it runs the query.
Oh, wow.
Yeah, it knows mathematically that it can skip scanning the partitions where that specific ID cannot possibly exist.
So it prunes partitions on non-partition columns without adding new indexes.
Yep.
That is brilliant. It's just this massive push for safety, predictability, and letting the core tools do the heavy lifting. And we see it everywhere. Like Amazon EKS just rolled out support for Kubernetes version rollbacks.
Which is a massive safety net for platform teams. Upgrading Kubernetes is traditionally a one-way street.
Yeah, terrifying.
If workloads or add-ons fail compatibility checks after the upgrade, you're stuck. You often have to rebuild the entire cluster from scratch.
And now they give you a 7-day window. If the upgrade goes sideways, you just reverse it. It makes the whole process reversible and takes the terror out of infrastructure maintenance.
You see that exact same pursuit of safety in the core runtimes, too. Look at Bun. They're rewriting massive chunks of their JavaScript runtime. They're moving from Zig to Rust.
Wait, why move away from Zig? I thought the whole point of Zig was that it's incredibly fast and gives you absolute control over memory.
It does, and they're keeping Zig for the JavaScript core bindings that require low-level C plus interoperability.
Right.
But manual memory management is risky at scale. For the high-level runtime code, they're moving to Rust. The mechanism here is Rust's borrow checker. It strictly enforces memory safety at compile time.
Right, forcing you to fix it up front.
Yeah, it forces you to resolve error paths and ownership issues before you ever run it. It slows down the first draft of the code, sure, but it eliminates entire classes of concurrency bugs in production.
It's that explicit trade-off. Give me boring and correct over fast and broken.
Exactly.
And AWS is doing something similar with CloudFormation Express mode. They overhaul the underlying state machine, speeding up infrastructure deployments by up to 4x. You get deployment confirmations in seconds now.
That tighter iteration loop is crucial. It speeds up human-driven workflows, sure, but it's also directly targeted at agent-assisted deployments.
Right, because of the feedback loop.
Yeah. If an AI is writing infrastructure code, you need it to fail or succeed instantly so the agent can learn and iterate. A 10-minute deployment delay just breaks the agent's feedback loop entirely.
To be fair to the other side of this argument, simplicity doesn't always mean staying small or retreating to legacy tools. Sometimes it means rethinking the entire foundation to remove the bottlenecks entirely.
And that brings us to the edge networks, specifically what Cloudflare is doing architecturally. They're operating at a scale that breaks traditional systems.
Let's talk about workers cache. This is a tiered caching system sitting right in front of Cloudflare workers.
It's a brilliant optimization. You configure it with a single line in the Wrangler configuration file.
Online.
Yep. If a response is cached, Cloudflare serves it directly from the edge node without spinning up the worker isolate at all. It eliminates the CPU charges entirely for that request.
And it supports stale while revalidate.
Yeah.
So it serves the old cached content instantly to the user, while it quietly triggers the worker to refresh the data in the background. It's huge for server-side rendered apps.
Yeah.
You can cache on-demand renders globally without having to pre-generate everything at build time.
They're also changing how monetization works at the edge with the monetization gateway.
Right.
It uses the BY402 protocol. This allows site owners to charge for access to web pages, APIs, or datasets directly through Cloudflare's infrastructure.
So if you have a proprietary dataset, or you built one of those AI model context protocol tools we talked about earlier,
Yep.
you don't need to build a whole payment stack with Stripe and user authentication. The edge infrastructure handles the settlement via BY402.
Exactly.
That is a massive enabler for paid agent access.
Right.
An agent can just pay for the API call it needs on the fly.
But to handle all this global state like caching, payments, routing, Cloudflare had to solve a much harder foundational problem. They are replacing Raft.
Raft. But Raft is the absolute gold standard for distributed consensus.
Yeah.
Every major distributed system uses it. Why on earth replace it?
Because of the speed of light, across 330 data centers globally, Raft struggles with availability. A round trip across the Pacific takes 150 milliseconds.
It's just too slow.
Yeah. Cloudflare built Meerkat, an experimental service powered by a new algorithm called Kupaxa.
So if Raft is a bottleneck because everyone has to wait for the leader to acknowledge a write across the ocean, Kupaxa sounds like it's abandoning the leader entirely. How do they prevent data collisions if all 330 data centers are writing at once?
Think of Raft like a strict classroom. You have a teacher, the leader. If anyone wants to speak, they have to raise their hand, wait for the teacher to call on them, and the teacher records what is said.
Makes sense.
If the teacher leaves the room, the whole class stalks until a new teacher is elected. It creates massive latency.
And Kupaxa.
Kupaxa is a massive, highly coordinated group chat.
Okay.
Everyone is talking at once. There's no single leader. All the replicas perform writes simultaneously. But through the algorithm's mathematical design, everyone perfectly agrees on the final record of what happened.
Oh, right.
It maintains strong consistency and prevents collisions even when individual servers or whole data centers fail without ever waiting for a leader election.
That is wild. No single leader, no timeouts holding everything up. It's rethinking the very foundation of global consensus to just bypass the speed of light problem.
It really is.
And while Cloudflare is doing that technically, we're seeing the exact same foundational shift happen geopolitically.
The push for data sovereignty, it's reshaping cloud-native design entirely, especially in Europe.
Yeah, the EU's proposed Cloud and AI Development Act, or CADA. It introduced this 4-tier sovereignty framework. It's literally forcing regulated enterprises to rethink their reliance on the big American hyperscalers.
Right. Imagine you're running a national rail operator, a major bank, or a telecom grid. You can't just spin up instances in a generic cloud anymore.
No.
You can't have your country's train schedules dictated by a foreign vendor's proprietary control plane. They're building fully sovereign cloud platforms.
And to do that, they're going straight back to open source foundations. Kubernetes for orchestration, OpenStack for the raw infrastructure, GitOps for operational consistency.
And the mechanism there is GitOps. It's about enforcing architecture and policy as code.
Right.
If a cloud vendor cuts you off, or a geopolitical event severs a network cable, you literally point your Git repository at new bare metal servers, and the infrastructure rebuilds itself exactly as it was.
Because sovereignty isn't just about where the hard drive sits geographically. It's about supply chain transparency and the ability to survive entirely on your own.
Exactly. It's a total pivot from convenience to absolute control. You pull everything back to tools you can inspect, audit, and run yourself.
Which perfectly encapsulates the whole tension we've been tracing. We have these AI agents capable of incredible autonomous complexity, but they're fragile.
Very fragile.
They hallucinate, they crash, they fail to follow basic schemas, and they completely lack the human context to fix a 3 a.m. outage safely.
And so the entire infrastructure world is building the padded rooms to contain them.
Right, whether it's deploying multi-agent Git-backed memory, relying on a rock-solid Postgres setup with a Tokyo connection pooler, or building entirely sovereign OpenStack clusters.
It's all about containment.
The immediate future isn't actually about how fast an AI can orchestrate a swarm. It's about whether our underlying foundations are boring and reliable enough to survive the chaos. It leaves you wondering, though, if we're walling off our infrastructure and retreating to safe, predictable tools just to manage AI right now, what happens when these agents actually learn to write their own secure infrastructure from scratch? If you want to suss out more of these notes, head over to vocaltechnologist.cyu. Vocal Technologist, see you soon.
Spoken Tech for your ears.